All right, so we left off with you guys trying to find the first six terms of the sequence. So here we have a of n equals 6 to the 1/2 n minus 1. So we know that our very first sequence, our a sub 1, is where we're starting, right? So we know that a sub 1 has to be 6, okay? And then we're dividing by 2 each time. So we have 6. 6 divided by 2 is 3. 3 divided by 2 is 3/2. 3/2 divided by 2 is 3/4. 3/4 divided by 2 is 3/8. 3/8 divided by 2 is 3/16. And this would be our sixth term. And this is that's my best. I'm going to do these braces, y'all. All right. Now it says find the a sub 0. Well, your a sub 0 is going to be the opposite of what you're doing. So a sub 0 is going to equal, and you can again, when I say opposite, it's going to show up in the math. So if I just plug in which for 0, n equals 0, it'll work itself out. So we have 6 to the 1/2 to the 0 minus 1, which leaves us with a sub 0 equals 6 to the 1/2 negative 1. When you have a negative power, that means that it's the reciprocal of it, correct? So the reciprocal of 1/2, a sub 0, and the reciprocal of 1/2 is means 2. So our a sub 0 equals 12. Now, was that work necessary? No, but it said to show support with work. So we're showing it with work why our a sub 0 is. So in your exponential form. Now, granted, you can write your exponential form in this format. However, if this is a multiple choice test, there's a possibility that it wants it f of n in its simplified least amount of character form, which means that we are going to write it in the format of f of n equals our a sub 0 times our r to n power, okay? So in this case, we now know our f of n. Well, we know f of n. We know that a sub 0 is 12. We know our rate of change, or sorry, our ratio of change is 1/2 n to the n. So this would be our function. All right, our exponential function model. All right, so continuing. Now we have a word problem. So this is where it comes down to is applying this to some situation, some real world situation. So Tim released a helium-filled balloon that rose 200 feet in the first minute. And each succeeding minute, the balloon rises only 50% as far as it rose in previous minute. Write a general formula, a sub n, that gives the number of feet risen during the nth minute of the balloon for time in the air. Okay, so we're looking for how much it's risen, not where it's located, not the height of the balloon. We're looking for where it would be and then how far it would have gone. Okay, so if I am figuring out where the balloon is located, so is that 200 feet? Sorry, guys. Okay, I'm sorry, guys. I'm back. So we're going to first create our model here. So what it's telling us is that it's rising 50% more than what it was before, right? So it's rising, but it's rising pretty slowly, okay? Its distance is going to be how far it's gone after that time, right? It's going to be the sum of how far it's gone. So we're writing our a sub n. We have a sub n, and the information that we know is 200 when n equals 1. So we have 200. And we know that it's 50%, so that's going to be 1/2 n minus 1, right? So we have that part done. Now we're going to fill in where it's at, or after how many minutes where it's located. So after 1 minute, it's gone 200 feet. After 2 minutes, it's now gone another 100 feet. After 3 minutes, it's now gone another 50 feet. After 4 minutes, it's now gone another 25. After 5 minutes, it's now going another 12.5. After 6 minutes, it's now gone another 6.25. After 7 minutes, we now will have 3 125ths. And then after 8 minutes, we'll have 1 1/4 to my handy dandy calculator, okay? That's why I had to go stop and grab. So I have the numbers ready. All right, so now that we've risen here, it's saying use the formula from part A to find the height the balloon reaches after 8 minutes. So this isn't the height of the balloon. This is how much is gone up. So to find the height of the balloon, it would be the sum of all of this. Okay, so in terms of minutes, it would be us adding all of this up to figure out how high the balloon has gone. So to find the height of the balloon, would be the sum of how far it's gone. How far it's gone. So to find the sum, that means I'm going to add 200 plus 100 plus 50 plus 25 plus 12 and a half plus 6 and a quarter plus 3 and 125 thousandths plus 1 and 5,625 10 thousandths. Okay, I'm going to add those up to figure out after 8 minutes how high has it risen. Because I'm now estimating because I can't actually, at a certain point, I'm going to not be able to measure, right? And so that's why we're here and we're going to measure it out from there. So we have, put that all in the calculator, find the sum. So 200 plus 100 is 300. 300 plus 50 is 350. 350 plus 25 is 375. 375 plus 12 and a half is going to put us at 387.5. 387.5 plus 6 is going to put us at what did I say just now? 385? 370? What was I? Let me just type it in. In the calculator, we're going to end up with 398.4375. And this is measured in feet above the ground. So after 8 minutes, after 8 minutes of time. Okay. All right. Hopefully that makes sense. That our A sub 0, our A sub 8 is not telling us like it's at 1.56. It's how much additional feet it has gone at that time. So the total would be, I would have to sum to find where it's actually located. So if you think about it, if you're thinking about the balloon floating, so the balloon is here, then it's 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 here. And now you're looking for the whole, how far has it gone? Okay, that's why we're adding it up. All right. All right. On our last example of our notes, we have Big Tech Electronics advertises a monthly payment plan for the purchases of the best-selling tablet. Buyers pay $50 at the end of the first month, $55 at the end of the second month, and $60.50 at the end of the third month, and so on for 1 year. What will the payments be at the end of the 4th, 6th, and 10th month? So these payments are progressing, right? So that they can have a good payment plan and allow you to grow. Is it pay as you grow kind of plan situation? So what we're going to quote is what we know so far. So we know that after the 4th, where are we at? I'm sorry. Here, what do we know so far? So we know that A sub 1, it is how much? $50. A sub 2 is $55. A sub 3 is $60.50. So we have enough to establish a pattern and a rule that we're following. So we need to figure out what is our R. So in order to find our 4th, 6th, and 10th payments, we need to figure out what is our R. So our R equals, and we're going to use our A sub 1 to start off to try to find our R. So using that, we have A sub n equals 50 times R to the n minus 1. Okay, now we can use either one of these values to figure out what our R is. I'm just going to use A sub 2 because it's right there. So I know that when I have A sub 2, it equals 55, which equals 50 times R to the 2 minus 1. Okay, 2 minus 1 is just 1. So I just have to do 55 divided by 50. So 55 divided by 50 means that our R equals 1 and 110. Okay, cool. So we now have our R, so now we can establish our rule. So our A sub n equals 50 times 1.1 to the n minus 1. So now it's asking what is your fourth, what's your 6, what's your 10? Well, you have a choice to do it by hand, or you can go to the calculator and find it by table. So we're going to model using our calculator. Because you're at home, I'm going to model it with Desmos, but I got to switch my Desmos calculator because right now it's in matrix form. So I don't want Desmos matrix. I want Desmos calculator. Ta-da! Here it is. So going to Desmos calculator, I'm going to put in our model. So our model is A sub n, but I'm going to put it in as a function. So I'm not going to use n, I'm going to use x. So we have 50, 1, and 110. Shift 6 to get my power, and it's going to be x minus 1. Okay. Oh, I needed to stay up there. X minus 1. I need you to stay with that x, bro. Parentheses, x minus 1. There we go. All right, you got to be smarter than the Desmos, okay? So I have that in. I want to look at the table. To access the table, I'm going to press this little gear, and it's going to give me my table. Okay, so now I have my table of values. The values that I need are A sub 4, A sub 10, A sub 6, A sub 4, and A sub 10. So I'm going to look at 4. I'm going to look at 6, and I'm going to look at 10 because those are the values that I've been requested. So here I go. Here are my values. So I know that at A sub n, so at month 4, it's going to be $66.55. At month 6, obviously I'm going to have to round, so it's going to be $80.53. And at month 10, it's going to be $117.90. Okay. If you don't round, you also can truncate in AP pre-cal. Truncating just means I cut off. So I can just say 52 and I can just say 89. Okay. But that's just if you're afraid to round. I'm just going to keep rounding because that's what I've been doing. So we know A sub 4 equals $66.55. A sub 6 equals $80.53. And we know that A sub 10 equals $117.90. Okay. You can look at the table also on a TI-84 to get the same result. Okay. So it says, how much will a customer pay for the tablet with this payment plan? So if they're doing this for an entire year, how much would the customer end up paying on this payment plan? Now, I will say that I don't know how to do this part that I'm going to show you with the TI-84 on Desmos. I don't know why I keep wanting to say the Desmos because it's not the Desmos. On Desmos, I'm not sure how I would do that. I'm not sure if it's possible, but I do know how to do what I'm going to show you on the handheld. So we're going to go there instead. So on here, we're going to actually use our stat edit window. And the reason why we're going to use stat edit is because it's going to allow for me to create the values that I need. Okay. So we go to stat edit, and I know that I'm looking at the values for a year. So we're going to be going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because this is for a year. This is our payment plan for a year. So 1, 2, not do that. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Could you just add them up, find the values and add them up? A1 plus A2, 100% you could. Let me make sure I fix my 11. Okay. However, I'm going to come here and let the table create it for me, and then I'm going to find the sum of it because it's just going to work in my favor. I'm going to go to L2. L2 is going to be defined based on what L1 is. L1 in this case is going to be my n minus 1, correct? So these are the values of my n. So when I'm putting in is my formula here. We have 50 times 1.1 to the, but it's going to be L1 minus 1. So I'm going to hit second 1 minus 1. And I'm going to hit enter, and it's going to find all those values for me. So it's going to go, okay, cool. Here you go. Here's all the values. Now, what's really cool is I want it to find the sum of these for me. So I'm going to go back to second mode, bye, and I'm going to go to second stat, and I'm going to go where it says ops. So what I wanted to do here is I wanted to find the sum. There you go. I'm sorry. I'm going to go to math, and I'm going to go to sum. And I'm going to press 5, and it's like, what do you want the sum of? Well, I want the sum of L2 because L2 is where all my values are. So second 2, hit enter, and it's going to find the sum of all my values for me. Okay. Again, I'm not sure how to do that in Desmos. I challenge one of you to figure out how to do it in Desmos, but I can gladly show you how to do it using the TI-84. Okay. The thing here, so your total equals your A1 plus your A2 plus your ... all the way up to your A12. And that's what we did. We found our A1 through our A12, calculated. So our total would be $1,069.21. Okay. All right. So then the next thing that we're going to do here, it says, write a general formula for the scenario as a geometric sequence and as an exponential model. So our geometric sequence, from my understanding, is that it's okay for our geometric sequence to just have A sub n, like A sub n equals 50 times 1.1 into the minus 1. For our function model, I think it wants us to get a little more professional with it in sense, meaning that we're going to find our A sub 0 and write it as our function model. So to find my A sub 0, again, couple options here. I can find A sub 0 manually. I can find it using the calculator. Like, there's plenty of ways to find your A sub 0 if you choose either one. We're multiplying by 1.1. So to find our A sub 0, we're going to divide by 1.1. That's simple enough, right? So I have 50 divided by 1 and 1/10. 50 divided by 1 and 1/10. And I end up with 45 and repeating 45. That's not pretty. Remember, fractions are our friends. So I'm going to turn this into a fraction. And I'm just going to leave it as 511ths because to me, that saves me. I know that I want to be exact, especially if this is money. I want to be as exact and down to the money as possible. So now I can write my function model. So my function model equals my A sub 0, which is 511ths, times my rate, which is 1.1 to the nth power. And that's my function model. And this is my geometric model. Okay, in some textbook, I wanted to point out that instead of using A for geometric, you may see it as a G, but it's the same thing. Okay. All right. So in terms of what's happening, what does this mean for this problem? Well, this is just basically an interest problem. Okay. It's an interest problem. So what this means in terms of this problem is that you're paying 100 plus 10% interest on your balance each month. So that's what your payment is doing. So you are paying 10% interest on your balance each month. And by it's all said and done, you will have paid this much. So it didn't say that it was the most affordable. It just said that it had a plan that was affordable. See where I'm going there? All right. So hopefully you guys feel pretty good about our 2A.2, our 2A.3 part. What was this? Part 1? 2A.2 part 2 and 2A.2 part 1. Please come to tutorials if you have any questions. Otherwise, prepare for your quiz over it. And have a great evening. Thank you.